Hey everyone, and welcome. Today we're jumping into a brand new explainer that's going to serve as your ultimate visual guide to Python foundations. Whether you're starting from absolute zero or you're just, looking to solidify your grasp on the underlying basics, you are absolutely in the right place. I am incredibly excited to be your guide today. We're going to set up your environment, break down the core syntax, and truly understand what happens inside your computer when you hit that run button. Let's get right into it.
Okay, let's dive into this. Here is our roadmap for today. Introduction to Python, how the PVM works, setting up your first program, code comments, variables, and basic data types. This structured roadmap will take you from zero to writing your very first lines of code.
All right, Section 1, Introduction to Python. Before we can write it, we really need to understand where this object-oriented, high-level scripting language actually came from.
Python basically reads somewhat like human language and is amazing for writing quick scripts to automate tasks. It was developed by a Dutch programmer named Guido van Rossum and officially released in 1991, heavily influenced by an earlier language called ABC. Now, what's really interesting about this slide is the name. When you hear Python, you probably picture a giant snake, right? Well, that's actually entirely wrong. Van Rossum named the language after the classic BBC comedy show Monty Python's Flying Circus. He just wanted a name that was catchy and a little bit mysterious. Over time, sure, the logo became a snake, but the true origin is pure comedy. No way, right?
So why has this language grown to have millions of developers today? First off, it's incredibly user-friendly. It's designed to be way easier to read and write compared to older languages like C++ or Java. But the absolute real superpower here, it's the community. Because so many people use it, there are over 1.3 million external libraries available. That's massive. If you want to build a web framework, process images, analyze text, or even manipulate audio, you don't have to reinvent the wheel. Someone has already written a library for it, and you can just plug it right in and start building.
Moving right along to Section 2, How the PVM Works. We are about to visualize the unseen magic that happens when you press Run.
When you type out your code and click the Run button, the output seems to just magically pop up on your screen. But to understand what's really going on, we have to clear up some beginner confusion and distinguish between two key concepts, a compiler and an interpreter. Think of translating a book from English to Spanish. A compiler translates the entire book all at once. Actually, scratch that. It creates a brand new Spanish book before you even start reading. An interpreter, on the other hand, acts like a live translator, reading and translating the book for you line by line in real time. This distinction is completely crucial for understanding Python's unique approach.
Let's walk through this brilliant illustration step by step. How does Python actually do it? First, you write your source code and save it with a .py extension. When you run it, it first hits a compiler, which translates your human-readable code into something called bytecode, saved as a .pyc file. Why not go straight to the machine? Well, this intermediate bytecode significantly speeds things up. Finally, the Python Virtual Machine, or PVM, steps in. This PVM acts as a middleman. It takes that bytecode, pulls in any external libraries you ask for, and acts as the interpreter to convert everything into binary machine code, literally zeros and ones that your computer's hardware can finally understand and execute.
Up next, Section 3, Setup and First Program. It's time to get hands-on and set up the actual tools we need to write some code.
Now that we know what's happening under the hood, let's install the tools. So the crucial point is right here at Step 2. When you download and install Python from the official website on Windows, you absolutely must check the tiny box at the bottom of the installer that says Add Python to Path. Seriously, do not skip this. If you do, your computer won't know where Python is installed, and you're going to get some really frustrating errors later. Once that's done, you install an editor like VS Code, grab the official Microsoft Python extension, and boom, you're ready. To write your first program, just use the print method. Think of print like a Xerox machine. Whatever text you feed into the parentheses as input, it spits out an exact copy to your screen as output. It really is that simple.
Section 4 introduces a vital habit for us: how to use code comments. Imagine this scenario. You spend hours writing 100 lines of complex logic today, and it works perfectly. But when you, or maybe a teammate, open that exact same file a year from now, are you really going to remember what that logic does? Probably not, right? That is exactly where comments save the day. They act as human-readable notes embedded right alongside your code. And the best part? They are totally skipped over by the computer. When that PVM we talked about is running your file, it sees a comment and just entirely ignores it. It has zero impact on your program's performance. It's just a note for your future self.
Python gives you two simple ways to leave these notes.
For a quick one-line explanation, use a single-line comment, which starts with a hashtag symbol. If you need to write a detailed paragraph, say explaining a complex math formula, you use a multi-line comment, which requires opening and closing the text with triple quotes. Getting into the habit of leaving good comments early on is definitely what separates a beginner from a real professional developer.
All right, on to Section 5, variables and their rules. This is the core building block of all programming. If you're going to write code, you're going to process data. Variables are how that data is stored. I want you to lean heavily into this analogy. Think of a variable simply as a labeled container or a physical box inside your computer's memory that stores a specific value. The syntax is beautifully straightforward. You write the variable name, an equals sign, and then the value. For example, A equals 10. The number 10 is placed inside the container labeled A. And if you ever want to prove this container physically exists in your machine, you can use Python's built-in IDE method to find its exact memory location.
And this brilliantly illustrates that when creating these container labels, Python is actually quite strict. Looking at the valid rules, your variable names can start with letters or underscores, and you can put numbers at the end. But for the invalid rules, you can never, ever start a variable with a number, and you can't use special symbols like the @ sign. Furthermore, look at the bottom here. Python is entirely case-sensitive. If you make a variable called PythonLife with capital letters and later try to print PythonLife in all lowercase, Python is going to throw an error because it sees them as two totally different containers.
Finally, Section 6, Basic Data Types. Because our variable containers need different specific shapes depending on what they hold.
Here is a quick map of the foundational types of values you'll be assigning all the time. You have your integers, or int for short, which are just whole numbers, like 1 or -2. You have floats, which handle decimal points, like 2.33. You have strings, which are text characters wrapped up in quotes. And for advanced math, Python even natively supports complex numbers with real and imaginary parts, like 1 + 3j. If you're ever sitting there unsure what type of data is inside a variable, Python has a super handy type method to tell you instantly.
Let's move to and see how this builds into perhaps the most fascinating data type for logic processing, the Boolean. A Boolean variable is rigid. It only ever has two possible states, true or false. But here's a really fun internal fact. Because computers ultimately run on binary, as we saw earlier with the virtual machine, Python internally views true as the number 1 and false as the number 0. They are quite literally mathematical values disguised in plain English text to make coding easier for us humans. It's pretty amazing.
And there you have it. We've explored the history, visualized the internal virtual machine, walked through setting up your environment, learned how to document our work with comments, and mastered the strict rules of variables and basic data types. You're no longer just looking at abstract concepts. You now have the solid foundational building blocks of Python ready to go. The environment is set, the syntax is clear. The only question left for you is, what will you build first? Thanks for joining me on this explainer, and happy coding!